The Air Force, as I mentioned, simplified the process considerably by bringing it down to 4 essential steps. I'm going to take you through the process first and then work a classroom problem for you. So we're doing the same cycle we've been in all 3 days, tell, show, and do. So you will get a chance in a few minutes to do this, all right? All right, look at the first one. It says, item A, it says problem, identification specifically defined. Before you can stop and find cause for a problem, you have to know what you're finding cause for. So the typical wisdom is to write a problem statement. So if you'll draw yourself a T up there like this on item 1, the problem statement is most easily articulated as an object and a defect. Now, ideally, if there is a perfect problem statement, it could be 2 words. That's perfect. In real life, I rarely get to 2 words. But what you want to do is distill it as tightly as possible. You don't want great big long paragraphs because, first of all, there's no way to deal with like this. You need it concisely done. A couple rules. One is always write the problem statement. Always is a tough word, but in this case I mean it. Always stop and write your problem statement. Now, test my thinking for a minute. Why do you think it's so important to always stop and write this problem? Actually, when you write it, you distill the emotion out of it, so you're 100% right. Because when you hear a problem, it very often is, you know, this and this could happen, and I'm going to die. And when you can get distilled down to a factual statement of an object and a defect, the defect being manifested usually on or about the object, then it's a nice clinical approach to it. Because it is not uncommon to start thinking you're solving a problem and realize an hour later that you have drifted into a sandbar over here. So as the manager of the problem process, it's very easy to say, well, that's a good point, Jim, but that's not what we're working on. And that sounds funny at times, but it really does happen. So one last rule about problems solving as a process. I could figure out who the smartest person in this room was. And since he's not here, we'll say it's Harley. We won't embarrass him. And we could say Harley's got everyone beat by 35 points of intelligence. And we could give Harley a problem that could take any 2 or 3 of the rest of us who are normal, mortal beings that do not walk on water, and we would always do a better job of problem solving than Harley would. There is truly a synergism that goes on in problem solving. It's locked into the brainstorming concept, but it's 1 + 1 = 3 for whatever it's worth. So as difficult as it is, you always want to go find 1 or 2 other people when you're working on significant problems to deal with. So a crowd's a good idea is what it amounts to. There's another thing that plays here, and it's ego. Jim, I got a problem. I could wrestle with this problem forever and probably not even think that I might be the cause of it. You come into the picture, first thing you say is, you're the problem. It would never dawn on me. So most of us kind of look at it objectively. We don't see ourselves as part of the soup. So there is a degree of objectivity that goes on here as well. So now you kind of got some rules. Write the problem statement, a 2-word statement, and whatever. Real quickly, we'll go through the process first, and I'll come back and lay it on a real problem for you. So now look at item B. It says probable causes. All logical possibilities should be listed and tested, and then select one. Now, select one is optimistic. It is possible to have 2 or 3. But in problem solving, your first goal should be to select 1 gross cause. Now, the accountants have a rule called the law of the diminutives. And what they say is, yes, it might be 5 or 6 mistakes in here, but more often than not, if we can find the big one, the other 5 or 4 don't matter. It isn't always the case. For example, I can remember a kid having a tube television. Remember those? And the picture went awry. Well, I went and tested the tubes. 10 tubes, 6 of them were in the weak zone. In that case, then all 6 of them were part of the cause. But that's relatively rare when things go wrong in a problem-solving process. Now, what you're really trying to do when you solve a process is you're looking for the cause to this problem. So go back to object and defect for a minute, and I want to define defect a little more clearly. Defect certainly can most easily be defined as a deviation from norm. In other words, I didn't used to have this temperature of 107 and now I do, so that's not good. But a defect can also be defined as a condition that you're no longer willing to accept. For example, Robin knows me personally, Mark does. I used to be up over 300 pounds. I was 300 pounds for a long time. I could argue that that wasn't a problem. That's norm, except it was a problem. And I was never going to solve that problem until I could say, guess what? Even though this isn't a deviation from my norm, it's a condition which I no longer want to live with. Now, one of your problems as a professional salesperson sometimes, solving problems and therefore selling a solution, is convincing somebody they have a problem. For example, anybody remember Studebaker car? South Bend, Studebaker car was built in, I know you won't believe this, a 5-story building. Now, how do you build a car in a 5-story building? Not easily. You have elevators on both sides, and you run the car through the first floor and you do whatever you do in it. You take it up the elevator and you run it through the second floor backwards and you do other things to it, put parts on it. Put it in the elevator and you go this way and you're getting pretty close to being finished. And this one you put all the finished stuff in it. This one you paint it and you bake it. And then you take it down the elevator and put it out in the lot.
This was an old wagon factory, but
that's how it started.
that building is a wagon factory.
That's how it started making, what do they call them, coaches, they go wagon.
Wagons for the Civil War.
Yeah. Now,
In that building.
that's right. 55,000 employees there, and they started not doing very well. Now, because at the time, domestic was their only real competitor. So Fords and Chrysler and General Motors were beating the hell out of them. So the consultants came in, and they looked at it, and the first thing they said to Studebaker is, you can't build a car in a 5-story building. Would you like to hear the answer over and over again? I've always done it this way. We used to build wagons here. My grandfather worked in this place. They never convinced them they had the problem. Now, that wasn't the only thing that demised these guys. But one Friday night, 55,000 jobs vaporized in South Bend, Indiana. And this building is thought by many problem solvers to be a significant cause. There was another cause which I think is interesting. Still tied into the building. How big a car can you build in this building?
As big as the elevator.
Big as the elevator. Remember the Studebaker? It was kind of a small car. Now it'd be in style today, but back then cars got long and wide and whatever. So when they sat down at the drawing board, they had a certain number of inches, bumper to bumper, and that was it. There were more problems than that, but that's considered that building. There are some efficiencies too that you lose by not having a continuous straight line operation, because every time you go into an elevator, you're confined by the number of minutes in the elevator, people doing that extra job. I don't know if you've ever been in an automotive plant or many manufacturing plants. Their processes are straight lines or real nice curves and stuff. These guys couldn't do it. But the point is, someone never sold them they had a problem, so therefore you never get to solve the problem. It's real easy for us to solve this problem now. Build a 1-story building. But if you don't believe you have the problem, if I didn't believe 300 pounds was a problem, why would I go on a diet?